In that video, we will make all the exercises about Pythagorean triples on that document. So let's start. The first one, we want to check that 5, 12 and 13 is a Pythagorean triples. So in first, to know if it's Pythagorean triples, we want to know the definitions of Pythagorean triples. And that definition is set by the equations a squared plus b squared is equal to c squared. So it's easy, let's just replace. We have 5 squared plus 12 squared is equal to 25 plus 144, and it's equal to 169. So 13 squared is equal to 69 too. We want to say just that 5, 12 and 13 is a Pythagorean triple. Let's make the second exercise. We want to check that 3 ends, 4 ends and 5 ends is a Pythagorean triple and prove that the set of Pythagorean triples is infinite, with n an integer greater than 1. In first, we will prove again that 3, 4 and 5 is a Pythagorean triples. We will take the same equations, and 3 squared plus 4 squared is equal to 25, and 5 squared is equal to 25 too. So we have a Pythagorean triples. Now we will multiply this Pythagorean triple by n, an integer greater than 1, and in n we know that there is an infinity of number. Like we will multiply this infinities of numbers with a Pythagorean triple. It wants just to say that a Pythagorean triples based on 3, 4 and 5 is endless. Now we will make the exercise 3. So, in the first exercise, we want to prove by contradiction that a Pythagorean triples can never be made of 3 odd numbers. To answer to this question, we will use two properties. In first, we know that the square of an odd number gives an odd number. So, for example, 5 squared is equal to 25. But we also know that the additions of two odd numbers will give an even number. For example, 9 plus 3 will give 12. But if we replace in the equations a squared plus b squared is equal to c squared, a squared plus b squared will give an odd number plus another odd number, and the additions of these odd numbers will give an even numbers. And c squared will just give an odd number. But a squared plus b squared will give an even number, and c squared will give an odd number if we care. So we can say that a squared plus b squared are difference of c squares, because an even number is obviously difference of an odd number, so it will never give an Pythagorean triples. So now let's make the fourth exercise. In this exercise, we want to apply the Pythagorean number theorem with m equal to 4, n equal to 3, and check that you get a Pythagorean triples. We will take the equations of origin, a squared plus b squared equal to c squared, and we will replace these equations by the theorem. To remember, a is equal to 2mm, b equal to m squared minus n squared, and c equal to m squared plus n squared. So, if we replace it in the equations, it made 2mn squared plus m squared minus n squared in parentheses squared equal to m squared plus n squared in parentheses squared. Now we will replace these equations with the number, because I remember m equal to 4 and n equal to 3. It will give in the first part 2 times 4 times 3 in parentheses plus 4 squared minus n squared in parentheses squared equal to 4 squared plus 3 squared in parentheses squared. It made, for the first part, 576 plus 49, that is equal to 625, and for the second part, C, it gave 625 too. So we can say that a squared plus b squared equal to c squared. So we have a Pythagorean triple. So now let's make the last exercise, the first exercise, the last one, and I think there are just to explain. We want to prove that if m and n are two positive integers with n greater than n greater than 0, then a equal to 2mn, b equal to m squared minus n squared, and c equal to m squared plus n squared is a Pythagorean triple. So we will base on the equations of origins. So then a squared plus b squared equal to c squared. We will replace it with the theorem. It will make again 2mn in parentheses square plus m squared minus n squared in parentheses square equal to m squared plus n squared in parentheses square. So we will develop it. It will make 4m squared times n squared plus n squared minus m squared in parentheses times m squared minus n squared in parentheses equal to m squared plus n squared in parentheses times m squared plus n squared in parentheses. It's hard. It made 4m squared times n squared plus m fourth minus 2m squared times n squared plus n fourth equal to m fourth plus 2m squared times n squared plus n fourth. So to conclude, it made m fourth plus n fourth plus 2m squared times n squared equal to m fourth plus n fourth times equal to m fourth plus n fourth plus 2 times n squared times n squared. So we made QED, or quote erat demonstratum, because a squared plus b squared is equal to c squared. So we finished the document, and I can say goodbye.